Hello, I'm Yana Trafaz and I work for the Athens Institute for Education and Research, which is a world association for academics and researchers. I'd like to welcome you to Atner's interview series where we interview the participants that attend our conference in Athens. Today I'm going to be interviewing Dr. Itzhak Orion, who is head of the Nuclear Engineering Department at the Ben Gurion University of the Negev in Israel. Hello, welcome to Athens.
Hello.
How are you?
Nice to be here.
Nice to have you here. So can you give me a brief academic introduction of yourself?
Yeah, I'm a physicist.
Mm-hmm.
My bachelor degree was in physics in Jerusalem, the Hebrew University. Well, it was a long time ago, but physics was the main interest for me because as a child I was very interested in the subject of astronomy, astrophysics,
Mm-hmm.
the stars. So
Yeah.
at the beginning I aimed to learn about that. But at some point I said to myself, well, the nuclear is much more fascinating.
Mm.
So I went from there to the second degree in Beersheba, where I'm staying now, in the University of the Negev, and started to learn about, it was actually research about what is going on inside the nucleus of the atom.
Mm-hmm.
The third degree, the PhD, was much more into application of nuclear engineering in the subject of locating radioactive gases and pollution that can be emitted in case of accident in a nuclear reactor. So it was much more practical and interesting. Then it took for me about 4 years to accomplish that.
Mm-hmm.
After that, I was traveling. I went to Brookhaven National Lab at the USA for 2 years with my wife. It was my daughter there, and I started there to be specific into theory of simulations of radioactive transport, everything that can be calculated using simulation was interesting, and I work on it. Since then, I'm working on simulations, a lot of simulations, because the calculation itself is not giving much of point of view to see what's going on, so you have to simulate, then you get the picture. And came back to Israel, to a position of researcher at the university, and now I have many students. I have some PhD students, master degree students. It's a whole group. All they are working on mostly on calculations, but also on experiments in the subject of radioactive radiation, many aspects of mainly radiation from the nucleus.
Mm-hmm. So what's currently your major area of research?
Nowadays, I'm much more interested in theory, even very open theory, like what is going on in the nucleus of the atom in general, how to explain how energy is transferred from the nucleus outside, which we are calling it radioactive, and how actually to simulate that to find better models that previously were introduced to us. Nowadays, I'm lucky, we have good computers everywhere, so simulations, you must have a computer, a good computer, but today it's not a problem. You have a lot of computers, you can make everything you like. The graphic is excellent thanks to games, things like that everyone likes to make. And my work is similar to a game now, because I'm looking at an electron, like how it travels through a line, or how it can be reflected from something, and how it transfers from one point to another, tracking its energy, how it transfers from one point to another point, and by that we found usually we find the interactions, their strength, properties. And this is always a very interesting and very important question for application as well as for pure physics.
So is this what you presented at the conference?
At this conference, I took a very unique question. It appears that we are looking at the complex inside the nucleus of particles, which are not the elementary particles. Inside these particles, like the proton is not a particle, it's a system. Also neutron. There is subparticles going in, like moving or doing something. Now there are many models. Some of the models are so complicated that sometimes it's hundreds of people that are working on the same calculation. These models are good for high energy, very high energy. I'm much more interested into a case where everything is very slow, very like to the ground base, when everything is very stable. Inside a regular atom, the nucleus is not like spreading around, it's just sitting there, very tight. And the nuclear force itself, its properties, it's like, until now it's a clue. There's a lot of speculations, there's a lot of open questions. To be honest, nobody knows what's going on. So I tried to put a model which is similar to the atomic model. My belief is there's one law in the whole universe. The same law repeats itself downscale, but even upscale. It can go like how two electrons can be seated at the same place in the atom. They are bounded. What are the law for that? It can be even to explain how two animals can sit together. I mean, upscale like this, or even human being, how they can share some of their needs when they are having the same place. Or if you go to the nucleus inside, so the nuclear force can be explained with the same words. So in this paper that I submit here, I'm actually taking the same idea of how the atom is built into a very tiny scale inside these particles of the nucleus, and I'm trying to show that it's the same again and again.
So why do you believe that it's the same? What makes you have this opinion?
Oh, well, long time physics is trying to be sophisticated, actually. And at some point, physicists start to talk in a language that the common people cannot understand. My point of view is the opposite. If it's real, if it's our life, it should be put in the same language that everyone can understand. There's a strong belief that the whole universe is made by one law. Unified theory is part of it, but even more than that. Life itself is under the same law like the matter itself. This is my belief, and I put it in some, there was an interview in Israel, and I put some questions about how to relate what is going on inside matter to what's going on with everything. What is the big question which should be answered with one simple answer, because my belief is that there's only one natural law. The nature is one. Even I believe that there's like a big program that we need to find. If we want to make a good research, we need to find what is the program. Maybe that can assist much more to the quality of life of human being, not only to make nice and big formulas, but also to learn from it.
Okay, So how were you introduced to Adler and what made you attend the conference? It's your first time here,
It's
right?
the first time, yeah.
Mhm.
Actually, during my research, I looked for some previous papers,
Mhm.
and I found a very nice paper that take into account that all the nuclear force is due to electromagnetic interaction, and I found that this paper was published under this kind of conference in Athens. And I said, oh, wow, that's nice, good paper from a good place. It's not far from Israel.
Mhm.
And I started to look for something like that, and I found in the internet the website. And so, okay, there's the next conference. Physics is one of the subjects, so I tried to attend. And very lucky, I even could attend, and I'm so happy to be here. It's very easy to get to Athens, and even to stay is very nice.
We're very happy to have you here as well.
Thank you.
So, can you tell us a few things about the higher educational system in Israel, and what do you think are its advantages and its disadvantages?
Okay, the education in Israel, after high school, we have to serve in the army.
Okay.
But after the army, you can go to one of the universities or the colleges. There are several good quality colleges also, recently developed in Israel, and many people are doing very well. They're going to engineering, to science, to any type of whatever can be learned to be professional. And many people can do that very nicely with a very good reputation of young girls that even go and open startups, companies, and a lot of computing is, well, it's a success.
Mm-hmm.
But recently, and even that was pointed by the Minister of Education in Israel, mathematics is going very low. Students, like, it appears that they are arriving to university without a background.
Mm-hmm.
And it's not how much to learn, it's how to teach the youngers to get into mathematics and to do it as it should be done, not very boring, but much more interesting, much more to make them into it like a researcher, not like to go all over again and all over again and make it a boring subject. And I think mathematics is very important for all the subjects. Even people that learn history, they should know mathematics, because this is pure idea. And this is a lack in Israel. On the other hand, how can we explain the success of higher education in Israel? So that belongs to a previous generation. For this generation, we have to find a way how to teach in a very interesting way, very complicated subjects, very boring subjects, you can say, but in a way which is much more modern, to fit it to this generation that is right now going on.
Okay, thank you very much.
Thank
Nice.
you.